Blue and AlphaGo. These are the famous example of narrow or weak AI. Then we have strong or general or strong AI. That is, general AI means this could perform any intellectual tasks with efficiency like a human. But up to now, there is no such system exists which could come under this general AI and can perform any tasks as perfect. Means there is no such system up to now which can perform any task as perfect as a human being. Means uh, that machine should have emotions and feelings like a human being. But this research is going on, but currently we don't have any such system. Then we have super AI, or we can say that super intelligence, and this can perform any tasks better than human with cognitive properties. This is a level of intelligence of system at which machines could surpass human intelligence. So for that, we should have characteristics like ability to think, to reason, solve the puzzle, make judgments, plan, learn, and communicate by its own. So this is again a hypothetical concept of artificial intelligence. So these are the three parts of three different categories of type 1 AI. Well, now, as I have already told you, the relation between ML and AI, AML can be thought as a subset of the larger field of artificial intelligence and that focuses on teaching computers how to learn without the need to be programmed for specific tasks. In fact, the key idea behind ML is that it is possible to create algorithms that learn from and make prediction on data. So it will learn from the data, again it will make prediction to the newly input data. So we have three components of machine learning. Okay, means the components to make machine learn. You see data set, algorithm, and features. These three components make machine learn. So data sets, collection of data. Machine learning systems are trained on special collections of samples, and these samples are known as data sets. And these samples can include numbers, images, tags, or any kind of data. Okay, so don't forget, image is also an important data with the help of which we can go for, object detection, or we can say that, a famous example is the tumor detection. So these are actually the different types of data sets. The next component is the features, and features are important pieces of data that work as the key to solution of the tasks. Actually, these features demonstrate to the machine what to pay attention to. Or you can consider them as the properties. That this property is important and this property is less important. So automatically that machine will focus on the most important feature. Then the next one is algorithm. No need to say that you algorithm how much impactful this one is while we talk about ML. Algorithm, the set of instructions actually, the way of solving a problem. Okay, so we may have different algorithm to solve the same tasks, and depending on the algorithm, the accuracy of the speed of getting the results may be difficult, means different. So in order to achieve better performance, sometimes you may combine different algorithms. And one such example is the ensemble learning, where we combine different algorithms to have or achieve better performance. Okay, so these three are the components of machine learning. And how actually the ML works, you will see that input data, then training examples. So from these training examples or training data, we build the ML algorithm. Then test data will be sent as input the ML algorithm, and from that the ML algorithm will give you the output. So data set, we have training data set and we have test data set. Okay, so model, that ML algorithm or that ML model will be built using that training set, and it can easily predict the accurate outcome for the coming or the new test data set. Clear? So we have different types of ML or machine learning. We have supervised learning, semi-supervised learning, reinforcement learning, unsupervised learning. So let's talk about each of them. Supervised means that a teacher helps the program throughout the training process. So there should be a supervisor. So this means actually this supervisor means there is a training set with labeled data. What I have said, labeled data. For example, you want to teach the computer to put red, blue, and green chalks into different baskets. So you should already have a data set where these different labeled chalks, okay, different labeled data means in this case chalks with different color should be there. So you should already have that label data set, then only you can go for applying your supervised learning technique to the new data. And one commonly used such supervised learning is classification and regression and algorithms. The famous ones are name-based, support vector machine, decision tree, K nearest neighbors, logistic regression, linear and polynomial regressions. And we use supervised learning for spam filtering, spam mail. Okay, we try to filter out the spam mails. Then language detection, okay, different language detection. Then we have computer vision, search and classification. These are the actually applications of the supervised learning. Then unsupervised learning is the opposite case. So you don't provide any features to the program, allowing it to search for the patterns independently. Say, for an example, you have a big basket of laundry that the computer has to separate into different categories, say socks, t-shirts, and jeans. But you don't have any idea about that. Your computer will not be feed some label data. How will you do that? You will do through clustering. Okay, and this clustering is kind of unsupervised learning and often used to divide the data into different groups on the basis of similarity. Obviously, all socks will show a kind of one similarity. Similarly, t-shirts will call kind of different similarity. Okay, second type of similarity. Then jeans will show you a different third type of similarity. So based on the similarity, you can divide that. So that is clustering. An algorithm which are famous in this area are K-means clustering algorithm, Dibya, mean shift. Then you have singular value decomposition, that is SVD. Then PCA, that is principal component analysis. Then LDA, that is latent direct allocation. Then latent semantic analysis, FP growth. These are the famous algorithms. And this unsupervised learning is good for insightful data analytics. And we use that for segmentation of data, anomaly detection, recommendation systems, risk management, fake image analysis. These are the applications. Then semi-supervised means what? Input data is a mixture of labeled and unlabeled samples. So the programmer has in mind a desired prediction outcome, but the model must find patterns to structure the data and make predictions itself. So that is semi-supervised. And reinforcement learning, a kind of how we human being learning actually. That is means through trial. Humans don't need constant supervision to learn effectively like in supervised learning. By only receiving positive or negative reinforcement signals in response to our actions, we'll still learn very effectively. Just give you an example. A child learns not to touch a hot pan after feeling pain. Means sometime for the first time it will touch the hot pan, it will realize that the child will realize that, yeah, if I touch the hot pan, I'll feel pain. So this is also an example of reinforcement learning. And one of the most exciting parts of the reinforcement learning is that it allows you to step away from training on statistical dataset. Instead, the computer is able to learn in dynamic, noisy environments such as game worlds or the real world. And games are very useful for reinforcement learning research because they provide ideal data-rich environments. The scores in the games are ideal reward signals to train reward-motivated behaviors. You can consider the example as Mario. An algorithm that we are using here is self-driving cars, games, robots, resource management. There we are using reinforcement learning. So meet you in the next session.